Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA GCSE Chemistry Paper 1 Higher Tier from 2022. Question number 4 is on the topic of energy changes. This question is about zinc and compounds of zinc. A student produces pure crystals of zinc chloride by reacting zinc oxide with hydrochloric acid. The equation for the reaction is zinc oxide, which is a solid, plus 2HCl, which is aqueous, and 2 zinc chloride, which is aqueous again, and plus H2O. The student adds zinc oxide to hydrochloric acid until the zinc oxide is in excess. Give one observation that the student could make to show that the zinc oxide is in excess. How would you know that's in excess? Now, if the zinc oxide is reacting to form zinc chloride, then the solid zinc oxide will remain if it is in excess. So, solid zinc oxide will be remaining. Why is excess zinc oxide used rather than excess hydrochloric acid? If you use hydrochloric acid, then if you're trying to, what are you trying to do? Doesn't actually clearly say, but if you're trying to make zinc chloride, which is going to be in excess, you don't want too much of the acid to be contaminating. It's hard to remove, so it's much easier to filter off the excess zinc oxide easily. Name one other compound that the student could add to hydrochloric acid to produce zinc chloride. One other compound that could be added to hydrochloric acid to produce zinc chloride. So we're looking for other compounds of zinc which is not zinc oxide. So you could add zinc hydroxide, zinc carbonate. Both of them will work. If you add zinc hydroxide, you're simply going to get zinc chloride and water. And if you add zinc carbonate, you'll get carbon dioxide plus the water and zinc chloride. Describe how the student should obtain crystals. There you are. So they're trying to obtain crystals. So you're going to wind up with a solution which you will need to evaporate the water and allow it to cool and crystallize. Describe how the student should obtain crystals of zinc chloride from a solution of zinc chloride by the process of crystallization. So heat the solution until crystallization point is reached. That's when you got rid of most of the water, about 90% of the water, and then leave the solution to cool and crystals to form. Zinc chloride is also produced in a displacement reaction between zinc and copper chloride solution. The equation for the reaction is zinc plus copper chloride gives you zinc chloride and copper. Complete the ionic equation for this reaction. So ionic equation, the zinc is going to lose electrons. Now remember, chlorine is in group 7, so it is going to gain 1 electron. So that means if it's forming zinc chloride, zinc is forming plus 2, and then 2 chlorine ions actually being formed as well when you form zinc chloride. So zinc is forming Zn2+, so that means the copper should be accepting those 2 electrons. So Cu2+ forms copper. Why is zinc described as being oxidized in this reaction? Now remember, oxidation is not just simply the transfer of oxygen atoms, addition or removing oxygen atoms, but it's also the transfer of electrons. Remember oil rig. Oxidation is loss of electrons and reduction is gain of electrons. So zinc is losing 2 electrons, hence it's being oxidized. Zinc atom loses 2 electrons. Zinc and copper can be used with another substance to produce electricity. Figure 7 Complete figure 7 to show how zinc, copper and another substance can be used to light a lamp. Label zinc, copper and the other substance used. So you have a lamp, and zinc is going to be a metal, copper is also going to be a metal. The other substance needs to be an electrolyte. So what you need is a beaker with two rods. One of the rod has to be zinc and the other one has to be the copper electrode. And what do you want to use? You should have a liquid which can transfer the electrons, and that usually is an acid. Here's a setup of what you could actually draw. So the same diagram, except I've got the light here with those curly lines. You should replace it with the circle and a cross. So just make it a bit bigger. So you've got the copper electrode and the zinc electrode, dilute sulfuric acid. You can't say simply, if you didn't know, you could call it the other substance. But you lose a mark. Simple diagram of that is going to be this. The electrolyte is the dilute sulfuric acid. You could label the hydrogen gas bubbles that is actually formed as well. That brings us to the end of question number 4, and I will see you in question number 5.